Hello, students. We need to talk a little bit more about organic nomenclature. We left off right here on this slide with number 7, and let's just dive right back into it. So number 7 says, when more than one of the same substituent is present, we do this. And remember that a substituent is exactly the same thing as a branch. You can use those two terms interchangeably. What we do here when we have a couple of branches that are exactly the same thing, like those two down there that are methyls, we're going to indicate on which carbon of the parent chain our branches are located, and we're going to go ahead and use Greek prefixes. So if we have 2 of something, we use di. If we have 3, tri, 4, tetra, and 5 is what? Penta. And then we have hexa, hepta, and 8 is, octa. Everybody knows 8. Okay, and that's going to indicate to the person who's reading what we've written how many of those branches are there. So let's go ahead and go down to the examples down here. And what we want to do is we want to go through the rules that we learned in the last video. And we're going to look for the longest continuous chain. And most of the time, our brains are going to want to go left to right. So if we go 1, 2, 3, 4, like that, we're going to have a 4-carbon chain. If we go 1, 2, 3, 4, that would give us a 4-carbon chain. If we did 1, 2, 3, 4, or 1, 2, 3, 4, those would all give us 4-carbon chains. So let's take some of this numbering off of here and clean up our picture just a little bit. Now, if we take a look at the fact that we can have a number of continuous 4-carbon chains, then we want to go to numbering in the direction that's going to give us the lowest numbers. Now, if we go left to right here, what we're going to have is we're going to have a 2-methyl, because we have a methyl group hanging off of the second carbon of the parent chain here. So that's the parent chain. And we're also going to have a 3-methyl because we have a methyl hanging off the third carbon there of our 4-carbon chain. Now the parent, we already said it, it's a 4-carbon chain, and that would be what? You are correct if you said butane. So what we're going to need to do is assemble this name. Now, if you have a couple of methyls, you're going to put those together and you're going to call that dimethyl. But you need to keep the numbers in the front because you need to tell your reader where those 2 methyls are located. So we're going to have one of them on carbon number 2 of the parent chain and the other one on carbon number 3 of the parent chain. So we throw the numbers up front, and when we have 2 numbers together, we put a comma between them. So remember, when we have a number and a letter together, we put what between those? We put a hyphen between those in the name for molecules. So here we're going to have 2,3 dimethyl butane. So you have a 4-carbon continuous chain, and you have 2 methyls that are hanging off of that 4-carbon continuous chain. Where are they located? Well, one of them is located on carbon 2 and the other one is located on carbon 3. Okay, moving on to the one on the right. So what we'll do is we'll number left to right and see that we have a 5-carbon chain. And if we tried to number differently, we would have maybe a 3-carbon chain. So we don't want to do that because 5 is longer than 3. And what if we numbered backwards? Well, we'd have 1, 2, 3, 4, 5. So you'd have another 5-carbon chain. So which one do you pick? Well, remember that we want our branches to have the lowest number possible. So if we go left to right, which is the black numbers, what we will have is we'll have a couple of methyls on carbon number 2. So we'll have a 2-methyl and a 2-methyl. If we numbered this chain right to left, the red numbers, we would have 2 methyls hanging off of carbon number 4. So that would be a 4-methyl and a 4-methyl. Now, which numbering system keeps the branches at a location that has a smaller number? Well, that's number 2. So we're going to go with that direction in numbering. So let me get rid of some of these numbers here. Also, you could do this. You could do 1, 2, 3, 4, 5, and that's still going to give us a methyl on carbon 2 and a methyl on carbon 2. If that's the longest continuous chain and the methyl to the left and the methyl on top are both branches. So that's going to end up being the same thing. So you could do that too, but most of us just want to go horizontal and want to go left to right. So we're going to back up and get rid of the green numbering. Okay, so we're back to this one right here, and we've got a methyl on carbon 2 and a methyl on carbon 2. So we have a 2-methyl, and we've got 2-methyl, and a 5-carbon parent chain is pentane. So in order to put this name all together, what do we need to do with our 2 methyls? Well, we need to call that dimethyl. Now, most of us are going to want to say 2-dimethylpentane, but that's not what we do in chemistry. If you have 2 branches, you need to label the location of both of the branches. So you need to say, I've got 2 branches, and one of them is on carbon 2, and the other one is also on carbon 2. Now, I know in our brains we're like, what? That's just kind of redundant, but you have to do it that way. So we have 2,2-dimethylpentane. So you've got a 6-carbon parent chain, and you have 2 methyls hanging off of it. Where are those methyls located? They are both located on carbon 2. Now, it's a very common student mistake to not put one of those 2s when you're writing one of these on a quiz or a test. So make sure that you're remembering to put the location of both of the branches. So if you're putting di here, you better have 2 numbers up front. If you're putting trimethyl, you better have how many numbers up front? 3, that's right. Even if it's 2, 2, 3, something like that, okay? Even if your number is repeating. Okay, moving on. Number 8 says, for multiple substituents, select the numbering scheme that gives a smaller number at the first point of reference. Okay, so taking a look at the molecule here, there's a couple of directions that we could number the chain. Now, if we number left to right, notice that what we'll have is we'll have 2 methyls on carbon 3 right there. And then we'll have a 3rd methyl on carbon 5. So that is going to give us 3, 3, 5 at the beginning. So it's going to be 3,3,5 trimethyl, and you can see that right here. If we were to number it in the right to left direction, which is on the bottom in the blue, what we would see is that we have a methyl on carbon number 5 and a second methyl on carbon 5, and we have a methyl on carbon 3. So we would have 3, 5, 5 at the beginning of the name right there. So what we have is 3, 3, 5, which is right here, versus 3, 5, 5. And the rule says, look at the first ones, 3 and 3, so those match, so you have to go to the next one. This one's 3 and this one's 5. This one is the lower number, so this is the combination of numbers that we pick. We do not add up 3 plus 3 plus 5 or 3 plus 5 plus 5. We don't do it that way. We just look at the first point of difference, which is the second number right there. And we say 3 is smaller than 5, so we're going with this one. So the correct name is 3,3,5 trimethylheptane. Now notice in the name, my friends, that you have 3 methyls, and so you're going to have 3 numbers up at the front. Even though you have 2 3s, so you have 2 of the same numbers, you have to do that. I've got 3 branches. What are they? They're methyls. Where are they located? 2 of them are going to be on carbon 3, so 3 and 3, and then you've got 1 of them on 5. If you just put a 3 and a 5 up at the beginning, we wouldn't know where that third methyl was located. Is it on the 3? Is it on the 5? Is it on the second one and you just forgot to put the 2? So you need to be precise with this. So if you've got 3 branches, you got to have 3 numbers up front there. Okay, moving on to number 9. We want to cite our branches in alphabetical order when we name things. And what that looks like is right here. We're going to have to first figure out what our longest continuous carbon chain is. And I'm just going to go ahead and tell you it's the horizontal carbon chain. So we're going to use this one right here. So I'm going to take that away. Now the question for us is are we going to number left to right? Or are we going to go right to left? Oops, I have just picked up an extra carbon somewhere. Left to right, I'm seeing 7, and on right to left, I'm seeing 8. Oh my goodness, why are my eyes so bad? What on earth? Oh, I'm missing number 6 in the red. I guess I can't count tonight. Terrible teacher. Okay, there we go. Oh, all right, 6, 7. Whew, like sometimes when you're super close to something, you can't see it. All right, are we going to do green or are we going to do red? Well, if we go left to right, what we're going to have is a branch off number 3, and we're going to have a branch off number 6. So 3 and 6. I guess I should write that in green, shouldn't I? So it matches up for you guys. So we're going to have 3 and 6. Now, if we go right to left, what we're going to have is we're going to have a branch off carbon 2, this one right here. And we're going to have a branch off carbon number 5. So which one are we going to pick? Are we going to pick 2, 5? Or are we going to pick 3, 6? Well, you're right if you chose the red and you said 2, 5. Okay, so let's erase the green. Bye-bye, green. Okie dokie, Smokies. So what we're going to have is we're going to have a 2-methyl. I'm going to write it up here so we can just write out what we have, and I have a little more space. And we're going to have 5. What is this 2-carbon chain right here? And remember, do not include the carbon that it's connected to. That carbon is part of the parent chain there. Don't grab the parent chain carbon. A 2-carbon substituent is called ethyl. Not Mildred, not Bertha, just ethyl. Alrighty, so we have a 2-methyl and a 5-ethyl, and we have a 7-carbon parent chain, which is called what? It's called heptane. That one's the weird one that a lot of people don't remember. So how are we going to put this together? Do we do 2-methyl, 5-ethyl heptane, or 5-ethyl, 2-methyl heptane? Well, you know what's really weird is, and I'm so sorry about this, my friends, the 2 does not come before the 5, which is how all of our brains are going to want to do it. What Iupac says is that in the branch name, you have to do alphabetical order. So here, E is going to come before M. So what we do against our will, because we want 2 to come before 5, is we're going to call that 5-ethyl, 2-methyl, heptane. And that's because E comes before M. Now remember, friends, that between a number and a letter you have hyphens, and that there is no space right there. All right, I know. But that's the Iupac Rules, so that's how we're going to do it. All right, looking at the problem towards the right, let's just go ahead and give ourselves a little more room over here, do some erasing, and take a look at this right here. Okay, looking for the longest continuous carbon chain. Let's just try left to right horizontal, because that's usually what our brains want to go to. So 1, 2, 3, 4, 5, 6, 7, 8. So then we would have a couple of methyl groups hanging off of carbon 4 and an ethyl group hanging off of carbon 6. What if we numbered backwards? We'd have 1, 2, 3, 4, 5, 6, 7, 8. So then we'd have 3, 5, 5. So in the first example, we're going to have 4, 4, 6, because we have our 2 methyl groups hanging off of carbon 4 in the blue chain, and an ethyl hanging off of carbon 6 in the blue numbering system. And if we go right to left with the red numbering system, what we would have is we would have our first branch at carbon 3, and then we'd have 5, 5. Okay, so the first point of difference is that very first number. We have 4 versus 3. And Iupac says that we're going to go with the lower number. So it's going to be 3, 5, 5. So let's go ahead and erase the blue numbers. And let's go ahead and just write down what we have. So we've got a 5-methyl, and we've got another 5-methyl, And we've got a 3 what? What's that 2 carbon chain? We did it in the last problem too. That's an ethyl. You got that right. Okay. And an 8 carbon parent chain is called what? That's called octane. We usually all know that one. Now, methyl and methyl, if we got 2 of them, that's going to become what? That's going to become dimethyl. All right, so what we have in order to put this name together is we have 5,5-dimethyl, and we have ethyl, and then on the end always comes the parent, so there's octane. So who comes first, the dimethyl or the ethyl? Well, now we're going to want to say the dimethyl because D comes before E, but what Iupac says, and I'm so sorry, my friends, Iupac says that di, tri, and tetra and any kind of hyphenated prefix like tersh, which is also T, or sec, which you can sometimes see as S, but not very often, are going to be ignored when it comes to the alphabetization for the order in naming. Ah! I know, and I'm so sorry about that. So E will come before M because we are not going to count di in the alphabetization. So we don't look at that D of di. So I'm going to write it down below here so I have some more room. We are going to have 3 hyphen ethyl, and then we're going to have 5 comma, because remember a comma comes between 2 numbers. 5 comma 5 hyphen dimethyl, and then what? Good, octane. So the E comes before the M. And remember, between a number and a letter, you have hyphens. And between numbers, you have a comma. And between the last branch and the parent right here, there is no space. Okie dokie, smokies. All right, now the second point here, bullet point, says if you have prefixes that are not hyphenated and they're not the Greek numbering system like di, tri, and tetra. So they're things that are part of the name like iso, neo, or cyclo. Those prefixes are not ignored. So say you have a isopropyl right there. And over here, you have a propyl. So there's a carbon here, here, and here. So you have propyl. That would be I versus P. It would not be P versus P because isopropyl is the name of this branch right here. You're not saying how many, like a di, tri, or a tetra. So that's how that one works right there. And let's go ahead and take a look at that rule again using the molecule right there. All right, let's back up and erase some stuff. All right, so we're going to do this molecule on the bottom here. Okay, now there's a million numbering possibilities here. So 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7, 8. Ooh, we found a longer one. So we're going to go ahead and we're going to erase red and green because those are 7-membered parent chains. Okay, 7 carbon parent chains. And we found an 8. Let's erase those and write them closer. Okay, so that's 4, 5, 6, 7, 8. Okay, so that's an 8-membered chain right there. Okay, what if we did 1, 2, 3, 4, 5, 6, 7, 8? Okay, well, if we did the red numbering, it would put 2 branches on carbon number 5. Whereas if you did the black numbering, you would get those branches off of carbon number 4. So can you see how the black numbering is preferable to the red numbering there? Good, because you want a 4, 4 for your branches instead of a 5, 5. Now there are a bunch of other possibilities, but in respect for your time, we're just going to go with this one right here because this is what's working. Okay, so if you want to do all the other possibilities, please see me in office hours and we can take a look at those. But let's just go with this because I know what I'm doing. Okay, well, most of the time, you know. All right, so we've got an 8-carbon parent chain, so that's going to be octane, and I'm just writing off to the side my thought process. It's very good for you to write down what you're thinking as you go, and if it's wrong, just cross it out or erase it. It's no big deal. Okay, so what we have is we have a 4-ethyl, so that's this one right here. That's a 2-carbon branch. And then we have a 3-carbon branch off of carbon number 4 of the parent chain. And a 3-carbon branch is called what? It's usually called propyl, but on this propyl, we're connecting the parent chain to the center carbon there. And that means it's not a regular propyl, it's a what? It's an isopropyl. And in the line bond formula, that'll look like a little snake tongue. And where we learned that is way back here in this chart that I gave you guys right here. You can see isopropyl right there. So you can see how the rest of the molecule that R there is connecting to the center carbon. Oops, I erased our R. Is connecting to the center carbon, whereas in a regular propyl, the rest of the molecule would connect to one of the end carbons. You might want to print this out right here and have it just sitting right there for you when you do the nomenclature homework. It will help a lot. Okay, so going back to our problem over here, whoop, and there we are. We've got a 4-ethyl, a 4-isopropyl, and octane. So in isopropyl, we just learned that we do not ignore the iso. Why? Because the rule says it right here, not ignored. Now, if you need to reference this, you should reference that because you're learning, and this is your reference, your notes here, my friends. So we have an E versus an I. Who is first in the alphabet, E or I? And some of us are going to need to do A, B, C, D, E, F, G. That's okay. I need to do that all the time. So what we're going to find is that ethyl comes first. So we have 4-ethyl 4-isopropyl. Even though they are both on the same carbon of the parent chain, you need to identify the location of both of your branches. If you have 2 branches, you need to have 2 numbers. If you have 3 branches, you need to have how many numbers? 3. Good. Okay, isopropyl, no space, octane. Woohoo! Got that one done, and we can move on to some more problems. Aren't you guys super excited about this? Yay, problems! Okay, so let's name the following molecules. So what we're going to do here is we're going to figure out if we're going to number forwards or backwards. And on the top left, just by looking at it, you can see that we're going to number backwards because our first branch will come on carbon 2. And if you numbered left to right, your first branch would come on which carbon? Carbon number 3. So we want to go 1, 2, 3, 4, 5 backwards. Okay, so what we have, I'm just going to write down what I've got and then piece it all together like I've been doing, is a 2-methyl and a 3-what? What's a 2-carbon branch? That's an ethyl. 2-methyl, 3-ethyl, what? What's a 5-carbon chain? That is pentane. Who comes first, methyl or ethyl? Ethyl. So we've got 3-ethyl hyphen 2-methyl, and I know we're going to want to put that 2 first, but no, because E comes before M, and then what? No space, and then pentane. Okay. Let's get wild and let's go down instead of to the right. And let's do this one right here. Alrighty, friends. So just looking at this, which way are you going to number? Left to right or right to left? We're going to go right to left again. 1, 2, 3. And now do we go left to this carbon or do we go up to that carbon? We're going to go up because that'll give us 4, 5. Whereas if I just kept going left, that would just give me a 4-carbon parent chain. So this, my friends, right here is actually the parent chain. Ah! Is that allowed? Yes, of course. You have free rotation around those bonds. So we've got a branch here, a branch here, and a branch here. So we have 2-methyl. We've got 2-methyl. And what? And 3-methyl. And we've got a 5-carbon parent chain, which is called what? Which is called pentane. Okay, so how are we going to put this together? Well, they're all methyls, so that's going to be trimethyl. And if you've got 3 branches, you need to have how many numbers? You need to have 3. So would we do 2-methyl, 2-methyl, 3-methyl pentane? No, you'd put 2, 2, 3 hyphen trimethyl. Remembering that between numbers you've got commas and between numbers and letters you've got hyphens. And then trimethyl, no space, pentane. And this is the part in lecture where I would say, does anyone have any questions? But because I'm recording the video, you have to ask your questions later. So let's go ahead and move on and do top right. So we've seen this little dog looking thing before. So we've got 1, 2, 3, 4. And it's going to be the same no matter which way you number this one. It just is. Go ahead and pause it and try a bunch of different ways, and you're still going to get that you have a couple of methyl groups off of carbon 2 and a couple of methyl groups off of carbon 3. So what's at the end of each of those points is a methyl group. And remember that the H3C is the same exact thing as CH3. Chemists just, like to confuse you guys because that's what we do. Okay, so we've got a 4-carbon chain here. So we're going to do 2, 2, and then what? 3, 3, hyphen. So you've got 4 methyl groups hanging off of your parent chain there. And what do we call it when we have 4 methyl groups? 4 branches that are all methyl. We're going to call that tetramethyl. And what is a 4-carbon chain called? So we're going to squish that in the side right there and call that butane. Oh, yep. Yay! I squished it in. So we've got 2, 2, 3, 3 tetramethyl butane. Woo! That's a lot. Alrighty. Let me do a little bit of erasing over here. Give myself some space for this beast over here. Okie dokie. So bottom right hand corner, what we're going to do is go, okay, I can do 1, 2, 3, 4, 5, 6, 7, 8, and that'll give me 4, 4, 5, or I can do 1, 2, 3, 4, 5, 6, 7, 8, and that will give me 4, 5, 5. Which one am I going to go with? 4, 4, 5 or 4, 5, 5? Okay, our first point of difference is right there. And 4 versus 5, the lower number wins. So we're going to do the red numbering system. There we go, right there, friends. Okay, so on carbon 4, I have 2 substituents. Now, at the end of each of my lines is a CH3. A branch that is CH3 is called what? Methyl. So I've got 4 methyl. Now, I've got another branch that has 1, 2, 3 carbons, and it's bonded to an end carbon, not to that center carbon. And remember that carbon number 4 is part of the parent chain, so we do not include it with that 3-carbon chain that's hanging off of it right here. What is that called? That's propyl. Now, carbon number 5 right here, we have a big T. And that one's pretty easy to remember. That's going to be our T-butyl. And oops, I forgot to put the 5 in the front. Okay, so you can write T-butyl or you can write terse butyl, but most of the time I see it written as T-butyl. Now what we have is we have M versus P versus what? Do we count the T or do we count the B? Well, what you're going to do is you're going to roll back here and you're going to reference your notes because that's what they're for. And it says right here, di, tri, tetra, and hyphenated prefixes like terse or T and sec or S are ignored for alphabetization. Oof, can't say that word. Alphabetization rules. Okay, so we're going to go with which? T or B? We're going to go with B. Okay, so woohoo! T-butyl comes first. So we're going to do 5 T-butyl. And then what? And then M comes before P. So we're going to have 4-methyl. And then we're going to have a 4-propyl. Whew, and an 8-carbon parent chain is called what? Octane. Yep, that's a doozy. And now you know why all of those ingredients on your shampoo bottle have these long names. Because this is how we name things in chemistry. So now you're going to look at your shampoo bottles when you're in the shower and be like, oh, there's a methyl. Oh, there's an ethyl. Oh! Yep, it's going to happen. Yep, there are nerds out there like me. Alrighty, let's draw. Drawing is so much better than naming. So what we do when we draw, we go whoa, all the way over to the end, and we go, okay, we've got a heptane. How many carbons is that? That's 7. And my most favorite way to draw this is line bond form, because you don't have to draw in all of the hydrogens. All right, remember, the first carbon happens when your pen hits the paper. So we've got 1, and that's when you count. 1, 2, 3, 4, 5, 6, 7. And then you count them, and you can draw in the numbers for yourself if you want to make sure you've got 7 carbons there, okay? And we do. So let's go ahead and erase those. Now, could you draw it the other way? You sure can. You can go 1, 2, 3, 4, 5, 6, 7. You could even draw 1, 2, 3, 4, 5, 6, 7 if you wanted to. All right, but I'm going to go with the first variety. So what we're going to do is we're going to go to the front and go 2-bromo. You never taught us that. I don't need to teach you that one. That one is really easy. What do you think is on there? We're changing it up a little bit. Well, that's a bromine. So you go to carbon 2 and you stick a bromine there, okay? And bromine on a hydrocarbon becomes bromo when it's a branch, and chlorine becomes chloro, and fluorine becomes what? Fluoro. Okay, so we've taken care of this part, so let's cross it out. But look, there's something else on carbon number 2, and that's a what? That's a methyl. So we're going to go ahead and draw methyl there. Now you can draw CH3 in, or you can draw it just as a stick like that, because at the end of the stick you have what? What do you need to assume is there? A carbon. And at the end it's going to be a CH3. That's what we know, because that's what we learned, okay? So you can draw the CH3 there, or you can just leave it like that. Now we're going to go on to carbon number 3, and we can see that we've got a chlorine there, and we have another what? Another methyl. So we'll go ahead and put chlorine, and this time I'll draw the methyl in. Usually you want to stick to the same format, so if at the top you didn't draw the CH3, you wouldn't want to all of a sudden draw it on the bottom. But I did, just to switch it up. Now, could you switch places with that chlorine and that CH3? Absolutely. They're both on carbon number 3. They can go either way. Okay, so we've taken care of that. Now we've got 4-fluoro. So let's draw our fluorine this way, okay? And what else is there? And methyl. We see it right there. Okay, so that is our 2-bromo, 3-chloro, 4-fluoro, 2, 3, 4, trimethylheptane. Yeah! And we have come to the last slide of this lecture video. Hallelujah. Okay, so 10 says, if the numbering of different groups is not resolved, the first cited group gets the lowest number. What on earth am I talking about? Okay, well, look at this hydrocarbon chain. So I've got 1, 2, 3, 4, 5, 6, 7. So that would give me 3-methyl and 5-ethyl. If I numbered 1, 2, 3, 4, 5, 7, that would give me 3-ethyl, 5-methyl. So I've got a 3,5 and I've got a 3,5. So there's no point of difference. You're going to have a branch on 3 and a branch on 5 either way. So Iupac says if this situation happens, what you do is you say, oh, okay, well, E comes before M in the alphabet, so E gets the smaller number. So we go with 3-ethyl, 5-methyl, and you can see that right here. We've got 3-ethyl, 5-methyl, and then heptane because you had a 7-carbon parent chain. Okie dokie smokies, we are done with this video. In the next video, I will do cyclic structures, which are fun. They're like my favorite thing to name. Alrighty, see you next time. Bye-bye.